Today we're going to look at dividing monomials, and just like everything else we do in algebra, the procedure is based on what's true in arithmetic. If I gave you the fraction 6 over 9, or 6 divided by 9, I think all of you could tell me that in reduced fraction, that's 2 times 3. The reason behind this is based on factoring. If I express 6, another way to express 6, as we did last night with prime factorization, is 2 times 3. I can also express 9 as 3 times 3. 3 divided by 3 is 1, which equals 2/3. This is what Mr. Walsh always loved to call dropping out the ones. I can use the same idea when working with variables. If I say x to the third, y to the second over x to the fourth, y, I can open this accordion up and say that this is x times x times x times y times y, and this is x times x times x times x times y. I may not know specific values for x or y, but I do know that any number divided by itself equals 1. So I can cross that out, knowing that it equals 1. I can cross that out, knowing that it equals 1. I can cross this out, knowing that it equals 1. And I can cross this out, knowing that it equals 1. So what I have left is x over y. Let's talk about something where, I don't know, the variables are kind of obvious. If I say, the exponents are obvious, I mean. If I say a to the fifth b squared over a to the third b to the, we'll make it fifth, even though this takes a lot of room. 1, 2, 3, 4, 5 a's multiplied together when I open up that accordion, times 2 b's, b times b, and then I have a to the third, b to the fifth, 1, 2, 3, 4, 5. So what happens is drop out the 1, 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 and what I have is a to the second over b to the third. Now you hopefully remember that the rule for multiplying monomials was to multiply the coefficients and add the exponents. And probably by now you've noticed that if I have 5 a's on the top and 3 on the bottom, 3 of them will cancel out, leaving these 2 on the top. If I have 2 b's on the top and 5 on the bottom, 2 of them will cancel out, leaving these 3's. When I cancel out, in effect, I'm subtracting. 5 minus 3 is a to the second. 5 minus 2 is b to the third. Hopefully, when you look at this, it's obvious that I am subtracting the exponents, but the reason why the a's ended up in the numerator was because there were more of them on the top to begin with. In other words, this exponent was bigger than this one, and vice versa for the b's. If there were 2 b's on the top, they're going to cancel 2 of the b's on the bottom, leaving 3. So a really somewhat messy way of saying this is that I'm going to subtract the exponents, and the answer goes in the part of the fraction where the exponent was bigger to begin with. Now let's get some numbers involved. If I look at the fraction 5x to the fourth over 15x to the second, well, based on what I just said, we know that 2 of these x's will cancel 2 of these, leaving x squared on the top because the 4 is bigger. Also, I know that 5 is a prime number, This is 3 times 5, so those cancel out. And my answer is x to the second over 3. What I really did here is I just simplified this fraction, simplified or reduced. If it were the other way around, if I had 15x to the fourth over 5x squared, I would have 15 divided by 5 is 3 on the top, and x squared. So the coefficients, really, I'm dividing, but sometimes dividing 5 divided by 15 comes out to be a fraction that's less than 1. So I would say the way to talk about what we're doing with the coefficients is we simplify or divide. Simplify meaning reduce, or divide when possible. So we're dividing our coefficients and we're subtracting our exponents in the simplest way of saying this. Let's keep looking at this further. Here's something that's important to note. If I say to you, what is 8 over 32? I think you know that that's 1/4. If I say 32 over 8, that answer is 4. I can put the 1 there, but I don't need to. If I wanted to extend this whole idea of factoring and dropping out the 1s to this problem, 8 is 2 to the third, 32 is 2 to the fifth. Need to extend this line. So 2, 3 of these cancel out. Notice when everything cancels out on the top, I need to remember that there's a 1 here because 2 times 2 times 2 times 1 is what I have in the beginning. So there's still a 1 there. It equals 1/4. And you can see over here, thinking about numbers, why that is. 8 divided by 32 is a fraction where the numerator is smaller than the denominator, so it's less than 1. On the other hand, when I reverse this, I've got 2 times 2 times 2 times 2 times 2, 2 to the fifth power for 32, and 2 to the third. So this is equal to 4. And I can put the 1 there, but 4 over 1 is the same thing as 4. Let's look at this exact problem, only let's use a variable for it. Let's say a to the third power divided by a to the fifth power. Here, I can see that 3 of these a's on the top are going to cancel 3 of them on the bottom, leaving 2. In other words, 5 minus 3 is 2, and it's going to be on the bottom. A squared will be on the bottom because the 5 was bigger. There were more there to begin with. But just as we said when we were working with the numbers up here, that's really 1 over a squared. Don't get fooled by this dropping out the 1 to think that there's nothing left here. It's still 1 on the top. On the other hand, if I have a to the fifth over a to the third, that's now I'm going to have 5 on the top and 3 on the bottom. So when I simplify that, I have plain old a squared. 5 minus 3 is 2, and it goes in the top of the fraction because, in the numerator of the fraction, because the 5 was more. There were more a's on the top, or numerator, to begin with. And some of the problems on the homework, it gets a little bit more complicated, of course, where you have to first simplify what we used to call the me first, or what we've been calling the me first. So if I have 2x to the third power divided by 2x squared, I have to first take care of this exponent, and this is going back to last chapter. Hopefully you know this. 2 to the third power is 8. X to the 1 times 3 is x to the third, because we raise the coefficient to the given power and we multiply the exponents. Now I divide that by 2x squared. 8 divided by 2 is 4, and x to the third divided by x to the second is x. And it's on the top because 3 is bigger than 2. So don't forget, when it's in parentheses and raised to an exponent on the outside, you have to take care of that first. All right, what about if I have 24 b to the third divided by 12 b to the third? Well, we can see that in this problem, we're going to divide our coefficients. 24 divided by 12 is 2. And that's on the top because 24 is bigger than 12. What is b to the third divided by b to the third? Well, any number divided by itself is 1. Each one of these cancels out. So our final answer is 2. There are no more variables. I would like to do one more that has a coefficient that's a little bit trickier. Okay, here's one other, a final problem. 3x to the 7th divided by 15x to the third. So I need to know how to reduce or simplify this fraction. I hope that you know that that's 1/3. I also have 7x to the 7th on the top, x to the third on the bottom. 7 minus 3 is 4, so it's going to be x to the 4th. And it will be on the top because 7 is bigger than 3. All 3 of these cancel out with 3 of those, leaving the 4 x's multiplied together on the top. There is one other aspect to tonight's homework, which I find that kids are usually pretty intuitive about. If I say 24x to the 5th, y to the third is equal to 8x squared y times what number? And I ask you to find that mystery number. There are a few ways of thinking about that. Some kids just like to say, well, what's missing? 8 times what gives me 24? Everybody knows 8 times 3 is 24. X squared times what gives me x to the 5th? Well, when I'm multiplying, I'm adding exponents. So I have 2 already, I need 3 more. Y to the first times what gives me y to the third? So that's y to the second. Others look at this and say, well, I know if I want to find out what times 8x squared y equals 24x to the 5th y to the third, I can divide by 8x squared y and find my answer. 24 divided by 8 is 3. X to the 5th divided by x to the second is x to the third. Y to the third divided by y to the first is y to the second. You can get the answer either way. It's just important that it makes sense to you. So in summary, what we're doing when we're dividing monomials is the first thing you want to do is reduce or simplify. If it's a fraction, reduce or divide the coefficients. And here's my very unmathematical language. Subtract the exponents of variables that are the same. The answer goes in the part of the fraction where the exponent was bigger to begin with. And don't forget, if everything cancels out in the numerator, need a 1. Okay, in other words, if I say x to the third over x to the fifth, that's x times x times x over x times x times times x times x times x. Remember, this was all times 1. That doesn't change it. These 3 cancel out and equals 1 over x squared. And the other thing that you just need to keep in mind is always follow Gremdas. Which means exponents first. So if I have, I don't know, 3x squared over 3x squared, before I can do this problem, I need to simplify the denominator so that it is 9x squared. And the top is 3x squared. These cancel out. 3/9 reduces to 1/3. And that's it for today.